Hi, welcome. In this video, we will solve binary tree maximum path sum asked by many companies like Amazon, Microsoft, Facebook, Apple, Uber, and Google.
Now let's check out one more problem, binary tree maximum path sum. Okay, this is marked as hard in the Leetcode. Okay, and this is quite conceptual. Okay, but we have solved similar type of problems, so we can easily solve this problem. Now let's see what is the problem. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. So basically, what is a path? Basically, a path is a sequence of node where each node has an edge connecting with them. So this is an edge that is connecting with them. Okay, a node can only appear in the sequence at most once. This is very important, right? So for a path, the node can appear, any node can appear for at most once, right? Not more than once. Note that the path does not need to be passed through the root. That is also possible. That path should not be pass through the root. So basically what we need to find, we need to find maximum path sum. Okay, so suppose there are two nodes here, right? This is one node, this is one node. So what is the path with the maximum sum? So I will say this is the path with maximum sum, right? What I will get a sum 2 plus 1 plus 3, right? So that will be 6, and that's why the output is 6, right? So the path sum of the path is the sum of the nodes value, right? So we basically did the sum of the nodes value, and given the root of the binary tree, we need to return the maximum path sum of any root. We need to return the maximum path sum. So here the maximum path sum is 2 plus 1 plus 3, that is 6. Here what is the maximum path sum? See, if I am taking this as an path, right? First of all, can you take this as an path? Can you take this as an path? No. Why? Because falsing this condition that at most once a node can appear in the sequence at most once. So if you are traversing from here and then you are again coming back to here, that means you are visiting 20th node, that is 20 value node, 2 times. Okay, so that's why this path is incorrect. You can't visit it. Okay. So what will be the correct path with maximum sum? Okay, so let's see. If I am taking this path, what I will get as in sum, or if I am taking this as in complete part, what I will get is 20 plus 7, 27, and 27 minus 1, so that means 26, which is not a higher value. Okay, if I am taking this as in path, we remove this one. Here we were getting 26, this as in path, right? What I will get as in sum, so 15 plus 20, that is 35, 35 minus 1, I will get 34. Yes, a bit higher value, but still less, I guess. So if I remove this path, and if I take this as in path from 50 to 7, passing through 20, what will the sum? 20, 15 plus 20, 35, and 35 plus 7, that will be 42, and that is the maximum value that you will get between the two nodes. Oh, so that's why the output is 42. Clear? Clear that we need to find maximum path sum any two nodes, right? We need to find the maximum value between any two nodes. Okay, now let's see how we can solve this problem. Okay, so let me first draw again the same template, so we can simply figure out few approaches. So for here, right, the distance between, if I am taking this node and this node, what will the maximum path? That I will get 4, 1 plus 2, I will get 3 only, right? For this path 3, for this path 4, but for this complete path I am getting 6. Okay, now understanding the last thing, minus 10, here we have 9, here we have 20, and here we 15, here we have 7, right? Why I'm not getting a maximum sum by taking minus 10? Because if I'm taking starting from minus 10, that will be a negative value, right? That will be a negative value. So I am taking this one, so it will make it positive, but overall the result will be still negative. Overall is the result will be still minus 1, right? So that's why this is not an answer. This path we are not able to take it. We are not able to take it this path. Take this example, that suppose you have all nodes with negative values. So let's suppose instead of 9, there is minus 9, then minus 15, then minus 7, then minus 20. Then which path is maximum path? Will you take this one, 20 or minus 7? Or will you take minus 9 or minus 10? You won't take any node, right? You won't take any path. Basically, the node itself, the least node value, will itself the maximum sum, right? So least node value here, minus 7 is the least node value. So this will be the maximum path sum. Because if I'm taking any path, if I'm taking the distance between two nodes, it will be minus 27, right? Here minus 7 will be the correct answer. So when all the nodes are with negative values, so the least value node will be the maximum, right? The least value node. So here that will be a minus 7, right? Or suppose if you are getting a single t, right? Suppose any value that is positive. Suppose this 20 is positive. So this will be the maximum, right? This will be the maximum because if it is contributing with any point, any node, minus 15 के साथ contribute, so the value will be less. Minus 7 contribute, value will be less. Minus 10 contribute, value will be less, right? So if you are contributing with any node, your value will be less. So that if you are positive, so that will be your maximum sum, right? Okay. Now see how we basically need to solve it. We got some observations, right? As of now, we got some observation. And if there are total negative values, so the sum maximum path sum will be the least positive, least negative value. If there are total negative values, okay. If there is a single positive value, then single positive value will be the answer. Okay. Now let's see. Let me create few binary trees. So one, and suppose one has a node 2, then it has 3. 3 is pointing to 4. 4 has a right node only, 5, and it has 6 or 7. But all values are positive. Okay. Now, even all values are positive. Let's take here 2. Even all values are positive. You can't take the all values, right? Because there will be a repetition, right? If I'm taking this and this path, there will be a repetition of this node, right? I am visiting 5 node twice. If I am visiting this 2 node like this, so there is a repetition of 3, right? So you can't take all the values, right? That is for sure, right? You can't take all the values. You just need to take the values with the maximum sum. Okay. Now let's see. Like take this example here. Here the maximum sum was 6, right? Maximum path sum was 6 because we are getting 2, 1 and 3, right? 2 plus 1 plus 3. So can I say if there is a single node only, and that has only a left node, okay, that is only a right node, okay. So the value will be the node value, right, plus left, okay. First of all, if it is maximum, so I can say left max plus right max. Why I'm saying this? I'm just checking this value. We have 1, then 1 plus 2 plus 3. That will be our answer. And for each node, this will be the value true. Let me explain you how. So we have 1, we have 2, we have 3, right? What I will do, I will calculate what is here, that is null. What is here, that is null, right? So what null will return? Null will return 0 value. Basically, it is not contributing, so it will return 0 value. So can I say what will be the value of this 2 is basically 2 plus 0 plus 0, and this will be the value, basically node value, but with your left max and right max. So now you got 2, you will return 2 here, right? Now for 3, this will be null, this will be null. So what will the value? That the value will be 3 plus 0 plus 0. So you will return 3, right? And what will the value of here? This node will be, basically it will be node value, that is 1 plus 2 plus 3. So that will be 6. But that is when we have not further nodes, right? When we have not further node. Remember this condition only. Remember this condition. See like here. what will is the maximum path? Let's figure out the maximum path. So I will take the positive values, okay, where I have positive values, and I guess this will be the maximum path here, right? Visiting each node once, this will be the maximum path. 2 plus 1, 3, 3, 6, 6, 4, 10, 15, and I guess 22, right? This will be the maximum path. Okay. Now see what are the values that you have left. You left this one, and you left this one. Okay. So if I talk about the value of this node, what it will be? Basically, it has null here, it has null here. So it will be 7 plus 0, right? According to the formula that we have generated, node value plus left max and right max. Then we have value will be value 0, 6 plus 0 plus 0, that is 6. Okay. For this node 5, what will the value? 5 plus 6 plus 7. Here you are getting 6, here you are getting 7, right? Remember, right? The maximum value of this node will be 5 plus 6 plus 7, right? But when you are returning to a further node, right, you can't give this value. You can't give this value because this is the total value of this node. This is the total value of this node. When you are returning to the your parent node, you need to take the maximum of this path or either this path, right? Suppose you have two paths, right, x and y. So you need to give the maximum of x or y. Okay, so here what is the maximum of between x and y? That is y. Okay, plus you will add the node value. What is your node value? That is 5. You will add it and then you will return. Now this is exactly that, basically how we find out the height of the binary trees. If you can remember that question, what we basically do, right? Suppose we have one node, then we have two node, 3, okay, that is 4, and suppose 5. So basically what we used to do, right? This is pointing to null, right? This is pointing to null. So what we do, we basically find max of left and right, and we return +1 because that's a count of one node, right? Okay, and when I am returning that, here I am getting +1, I will return this to +1, right? Here also I will get find null, right? And here that it will return +1 because max of left and right both are null, 0, +1, and I will return here +1. Now what I will do, I will here, like from here +1 I will return 2. But let's see, here you are getting null value. So what you will do, you will find out that you are getting max of what is left, it is returning 2, what is right, it is returning 0. So max of 2 plus 1 you will return. So what is max of 2 plus 1? That is 3. So you will return 3, right? So here you are returning 1, right? And here the same, like here you will return 2, right? Basically 1 plus 1 node here, then here you will return plus 1 node here 2, and this will be 2, the max will be 2, and here you will return 3, it will return 4. I guess I lost the 1, but if you can remember that basically we used to do this thing for calculating the height, right? We add 1 because for the node, right? Similarly the same step we are doing here, right? I am calculating x and y, and whatever the maximum is, because I need to take the maximum per sum, whatever the maximum, I will simply take that and I will add the node value and I will pass to the parent, right? But for each node I will calculate this sum, 5 plus 6 plus 7, right? And I will find out if I am getting maximum or not. Similarly here, right, here this is null, so basically it will return 0. It is returning, what is it is returning? It is returning 5 plus 7, that is 13, 12 I guess, 12. So it is returning 12, it is returning 0, right? So what it will return to it? To 3. It will return of max of 12 comma 0, right? So from here you are getting 12, from here you are getting 0. So the value will be 12 max, and you will return 12 plus 4. Basically here the node value 12 plus 4, and you will return to it, that will be 16, right? So now see, you are getting 16, and from here you will get max 2, right? Which is maximum 16. So you will return 16 plus 3, that will be 19. So you will return 19 to it, right? Now from here you are getting value of 2, right? So you will return 2, right? And like for this value, now for this node, see, now there will be a concept of this one adding all the values. So I am getting 2. From here I am getting 19. What I will do, I will say 2 plus 1 plus 19. That will be my maximum. That will be 22, right? So what we understood so far, to calculating a node value, suppose we have one node like 1, to calculating a node value, right? It will always be the node value plus value from the left, positive value from the left first, positive value from the left, positive value from the right. Why I am saying positive value from the left, from the right? Take this case, you have 1, okay, and you are having -2 here and -3 here. So will the node value will be 1 plus -2 plus -3? No, the node value will be 1. When I said when there is a single positive value, the node value will be the maximum sum, right? So you will take only positive values from the left hand. So forever a node, if there is a node value plus positive left plus positive right, that will be a node value. But there is a parent node, and if you are passing to the parent node, like here, if you are passing it to the parent node, what you will do? You will always take the maximum of your left positive again. Here also, I am not going. They both are negative. I am not going to transfer a negative maximum. I am always taking a positive value of left, positive value of right. Okay, so I will take a maximum positive value left and right, and I will add the root dot value. Okay, whatever the node value is, and I will transfer to it, and I will transfer to. Okay, let's try to solve one question. Okay, by using the same concept, and then you will get a bit of idea. I'm not saying the complete sense, but yeah, you will get a few of these steps that how I am basically proceeding it. So what I will do, let's take the same example that we got in our notes, that we have this 10, okay, and there was 9, and there was here 20. It was -10, but I am taking a positive value. I just need to figure out the maximum sum. 15 and 7. What will be the maximum sum? Maximum sum will be the total value, right? Okay. So what I will do, I will take one max value that will basically start from -infinity. It will basically track the maximum value that I am getting, right? It will track the maximum value that I am getting. And let's take -10 only. So let's see what we will get as an answer. We will get this node maximum sum. So let's see how we will get it. What I will do, okay, basically I will call start from the root function. I will call left, right, okay, and I will suppose first I will call the left, suppose, right? I will call the left function, right? So I called it here, right? Then called right, I called it here, I reached here, right? So I called left, I got null value, right? So this null value, what it will return? It will return 0, right? Then called right, I got null value, it will return 0, right? Now what I will do, I will find the node value. How I will find the node value? It will be basically 15, positive value from the left is 0, positive value from the right is 0. The value will be 15. So here I am getting 15. So far the maximum value I am getting, that is 15 only. So my maximum will be updated from -infinity to 15. Okay. Now whenever I am passing a value, what I will do, I will find max of left and right, right? So when I am passing here, I am getting only 15, right? There is no max, no, like here 0, 0, and I am passing the 15, right? So the value will be 0 plus 15. So I am passing a value of 15 here. Okay. Now what I will do, I will go for this path, right? Again I will calculate for this path. I am getting null, I will return 0. Null, I will return 0. So what will node value of this one? That will be 7 plus 0 plus 0. Okay, so that is 7, which is not greater than max, so I won't update it. Alright, it will get 7 here. Now what I will do, I will pass here as well the maximum value. So it will be maximum of this path 0, maximum of this path 0, and plus your root.val, that is 7. So it will return 7, 0 plus 7, that means it will return 7. What will the value of this node? Let's see. This value will be basically what you are getting from here, 15. What is the value? 20, and what you are getting from right, 7. So 15 plus 20, 35 plus 7, that will be 42. You are getting 42, which is greater than max, so you will update it. Okay, you will update it. Now 42 value, but what you will return to this node, what you will return the max of it. You will return max of 15 and 7 and plus 20. Max of 15 and 17, what it will be? 15, right? So you will return 15 plus 20, that will be 35 you will return. Okay, okay. Now you are here, you will calculate for this value, right? 9, here 9 pointing to null, it will return 0, pointing to it will return 0. So what will the node value of 9? That will be 9 plus 0 plus 0, that will be 9 only. Okay, now when it will return to it, it will find the maximum of 0 comma 0 plus 9, so it will return 9 here. Now what will be the node value of this node? Okay, what will be the node value of this? Again we got 9, but 9 is not greater than 42, so I have not updated it. Okay, now let's check this value. I am getting minus 10. From here I am getting 9, from here I am getting 35. So what I will do, I will take the maximum of it. So let me use green pen only, use maximum of it. So I will say maximum of 35, 9 I will take it, plus I will add the node value, that is minus 10. So I am getting 35 maximum plus 10 if I add it, plus that is minus 10. So if I add it, it will be 25, which is not greater than maximum. So I won't update it. Okay. And that's it. I will return the value. Okay. And what is the maximum value that I have stored? That is 42. So that's an answer. Suppose instead of minus 10, if it is a 10, then what will be the node value? What is this node value? Noting with the yellow pen. It will be maximum of 35 comma 9 plus 10. So then it will be 35, right? And what I will do, I will say 35 plus 10, that will be 45. So 45 it will return. 45 it will return. But what will the node value here? Node value will be always 9 plus 35 plus 10. So that will be 45 plus 9. That means 54. Here also we have calculated not node value. This is the passing value. The node value here will be minus 10 plus 9 plus 35. Right, so it will be minus 1, so it will become 34. So here the node value will not become 25. 25 is the passing value that it will pass to parent. The node value will be 34, again which is lesser than 42, so that's why. But suppose if there is a 10, then the node value will be 9 plus 35 plus 10, that will be 54. See, 9 plus this path na, right? So what will the total sum? 9 plus 10 plus 20 plus 15, sorry, this path. 15, 20, 10 plus 10, 9, right? This will be the path. So are you getting that we are playing with two values? One is passing value, okay, passing value to parent. One is node value and passing value. Okay, let's understand this. What is passing value and node value? Basically node value is the node, the positive left, say positive left and plus positive right. This is your node value. You are adding it. But for finding a passing value to parent, what you are doing, you are finding the maximum of positive left, positive right, and you are adding, basically you are adding the node value to it. So yeah, this will be our approach. And if you want, we can give you a pseudocode. Otherwise, we can simply check out the code implementation of it. We can directly check the code implementation, and then I will give you a dry run of it. Okay. So let's see. Let's check out this code implementation. Then we will do the dry run of this code. Basically, how this code will work. Okay. So yeah, let's check the next video, the code implementation of this.